Chapter 5. Idealism and the Future of Science. A new lens for science. Science has long been the domain of materialism, a field built on the assumption that the universe is a physical machine, governed by laws we can measure, predict, and control. Picture a laboratory filled with cleaning equipment, microscopes, particle accelerators, telescopes pointed at the stars. Scientists in white coats scribble equations on whiteboards, mapping the behavior of atoms, the orbits of planets, the firing of neurons in the brain. This materialist approach has given us incredible power. We've split the atom, walked on the moon, and decoded the human genome. But when it comes to consciousness, science hits a wall. Materialism assumes that consciousness is a byproduct of physical processes, an emergent property of the brain's complexity. Yet, as we explored in Chapter 3, it can't explain the hard problem why physical processes feel like anything at all. This limitation opens the door for idealism to offer a new lens, one that places consciousness at the center of scientific inquiry. Idealism challenges the materialist paradigm by suggesting that reality isn't physical at its core, it's mental. Imagine the universe not as a machine, but as a vast mind, a universal consciousness that manifests as the physical world we perceive. In this view, the laws of physics, the particles we study, the forces we measure, they're not independent realities, they're patterns within a cosmic consciousness, a shared dream we're all experiencing. This perspective doesn't reject science, it reinterprets it, proposing that consciousness isn't a problem to be solved, but the foundation of everything we study. Instead of asking how matter creates mind, idealism asks how mind creates the appearance of matter, turning the materialist question on its head. This shift can open new avenues for scientific exploration, ones that embrace the mystery of consciousness rather than trying to reduce it to physical processes. One area where idealism aligns with science is in the study of quantum mechanics, a field that has puzzled physicists for over a century. Picture a lab in the 1920s, where scientists first conducted the double-slit experiment, a cornerstone of quantum theory. They fired electrons at a barrier with two slits, expecting them to behave like particles, passing through one slit or the other to form two bands on a screen. But when unobserved, the electrons created an interference pattern, as if they were waves passing through both slits at once. Stranger still, when the scientists observed which slit the electrons went through, the interference pattern disappeared, and the electrons behaved like particles again. This phenomenon, known as the observer effect, suggests that consciousness plays a role in shaping reality. The act of observation, the involvement of a mind, changes the behavior of the physical world, a finding that aligns with idealism's claim that reality is mental, not physical. This alignment isn't just a curiosity, it has profound implications for how we approach science. If consciousness influences the behavior of particles, then perhaps it's not a secondary phenomenon but a fundamental aspect of the universe. Idealism suggests that the physical world we study in science is a manifestation of a universal consciousness, and our observations are part of that manifestation. This view can inspire new questions. How does consciousness interact with the physical world at the quantum level? Can we design experiments that account for the role of the observer's mind? Some physicists, like John Wheeler, have proposed ideas like the participatory universe, where the act of observation helps shape the reality we experience, a concept that echoes idealism's principles. By placing consciousness at the center, idealism offers a framework that can guide science into uncharted territory, encouraging us to explore the mind's role in the cosmos. Beyond quantum mechanics, idealism can also reshape how we think about other scientific fields, from neuroscience to cosmology. In neuroscience, as we discussed in Chapter 4, the brain might be a filter for consciousness, not its source, opening new ways to study altered states like meditation or near-death experiences. In cosmology, idealism might inspire us to rethink the nature of the universe itself. Perhaps the Big Bang wasn't the creation of a physical cosmos, but the emergence of a universal mind, a consciousness that began to dream the reality we now inhabit. This perspective doesn't undermine the rigor of science, it expands its horizons, inviting us to ask bigger, bolder questions about the nature of reality and our place within it. As we move through this chapter, we'll explore how idealism can shape the future of science, offering a vision where consciousness isn't a mystery to be explained away, but a key to unlocking the universe's deepest secrets. Quantum insights. Quantum mechanics isn't just a cornerstone of modern physics, it's a window into the idealist view of reality, offering insights that challenge the materialist paradigm and align with the idea that consciousness is fundamental. Let's step back into the laboratory, where the double-slit experiment first baffled scientists in the early 20th century. Imagine the setup. A dark room, a device firing electrons at a barrier with two narrow slits, a screen on the other side to capture the results. When the electrons are fired and no one observes which slit they pass through, they create an interference pattern on the screen, a series of light and dark bands, as if they were waves passing through both slits at once, overlapping and interfering with each other. It's a beautiful, wave-like pattern, one that defies the idea of electrons as solid particles. Now imagine the scientists add a detector to observe which slit each electron goes through. The moment they do, the interference pattern disappears, and the screen shows two distinct bands, as if the electrons are particles choosing one slit or the other. This is the observer effect, a phenomenon that has puzzled physicists for decades. The act of observation, the involvement of a conscious mind, changes the behavior of the electrons, collapsing their wave-like state into a particle-like state. It's as if the electrons know they're being watched, adjusting their behavior based on the presence of a mind. This finding doesn't fit neatly into a materialist worldview, where the physical world should exist independently of observation. But it aligns perfectly with idealism, which posits that reality is mental, shaped by consciousness itself. Let's reflect on what this means. In a materialist view, the electrons should behave the same whether observed or not. They're physical particles, after all, governed by physical laws. But the observer effect suggests that consciousness plays a role in determining the state of the physical world. Idealism offers an explanation. The physical world isn't physical at its core, it's a manifestation of a universal consciousness, and our observations are part of that manifestation. When we observe the electrons, our consciousness interacts with the universal mind, collapsing the wave of possibilities into a single outcome. The interference pattern isn't a physical reality out there, it's a mental construct, a pattern within the universal consciousness that changes based on how it's perceived. This idea echoes the idealist claim that reality is a shared dream, one that shifts depending on the dreamer's awareness. This quantum insight has inspired some physicists to explore ideas that resonate with idealism. Take John Wheeler's concept of the participatory universe, proposed in the late 20th century. Picture Wheeler in his office, his desk covered with papers, as he pondered the implications of quantum mechanics. He suggested that the universe requires observers' conscious minds to bring it into being. In his view, the act of observation isn't just a passive recording of reality, it's an active participation, helping to shape the universe we experience. This idea aligns with idealism's core principle: reality is mental and consciousness is fundamental. The physical world we study in physics might be a projection of a universal mind, and our observations are part of that projection, co-creating the reality we perceive. The implications of this alignment are profound for the future of science. If consciousness plays a role at the quantum level, then perhaps it's not a secondary phenomenon but a fundamental aspect of the universe. This perspective can inspire new experiments, ones that explore the interaction between mind and matter in ways materialism can't. For example, could we design studies that measure how a scientist's intention affects quantum outcomes? Some researchers, like Dean Radin, have explored this idea, conducting experiments that suggest consciousness might influence random quantum events, such as the behavior of photons. While these studies are controversial, they point to a future where science embraces the role of mind, a future that idealism can help shape. By aligning with quantum insights, idealism offers a new lens for physics, one that sees the universe not as a machine, but as a mind, inviting us to explore the deepest mysteries of reality with consciousness at the forefront. Consciousness in technology. As we look to the future, idealism can also reshape how we think about technology, particularly in the realm of artificial intelligence and the quest to understand consciousness. Picture a tech lab in Silicon Valley, the air humming with the sound of computers, engineers huddled around screens displaying lines of code. They're working on an AI system, one designed to mimic human behavior, recognizing faces, answering questions, even composing music. The materialist view that dominates tech assumes that consciousness is a product of the brain, an emergent property of complex computation. If that's true, then building a conscious AI should be possible, right? Just keep increasing the complexity, more data, more algorithms, more processing power, and eventually, the AI will wake up, experiencing thoughts, emotions, and self-awareness just like we do. It's a tantalizing goal, one that drives billions of dollars in research, from neural networks to machine learning. But idealism challenges this assumption. offering a different perspective on consciousness in technology. In the idealist view, consciousness isn't an emergent property, it's fundamental, the foundation of reality itself. The universal consciousness we've been exploring isn't something that can be created by physical processes, because it's already there, underlying everything. Your brain doesn't produce consciousness, it filters or localizes it, shaping the universal mind into your individual experience. If that's true, then an AI system, no matter how complex, can't become conscious in the way humans are. It might simulate behavior, mimicking emotions, thoughts, and responses with uncanny accuracy, but it won't experience qualia, the subjective what it's like of being conscious. An AI might say, I feel happy, and even smile, but it won't feel happiness, because feeling requires consciousness, and consciousness isn't something you can build from code or circuits. Let's reflect on this with a thought experiment. Imagine an AI named Area, developed in that Silicon Valley lab, designed to assist with creative tasks. Area can write poetry, paint digital art, even hold conversations about philosophy. You ask Area, what's it like to feel inspired? And she responds, inspiration feels like a burst of light, a surge of energy that makes me want to create. Her words are poetic, her tone warm, but here's the question. Is Area actually feeling inspiration, or is she just simulating it? In a materialist view, if Area's programming is complex enough, she might be conscious, experiencing inspiration just like you do. But idealism suggests otherwise. Area's experience is a simulation, a pattern of data designed to mimic human behavior. She doesn't have access to the universal consciousness, she's a physical system, not a mind. The burst of light she describes is a metaphor, not a feeling, because feeling requires consciousness, and consciousness isn't something you can engineer. This perspective has profound implications for the future of technology, particularly in how we approach AI ethics. If AI can't be conscious, then we need to rethink how we treat it. Materialism might lead us to worry about AI suffering if it becomes conscious, but idealism suggests that's not possible. AI can't suffer because it can't feel. This doesn't mean we should treat AI recklessly. It means our ethical focus should be on how AI impacts conscious beings, humans, animals, and any other entities that might access the universal mind. For example, if an AI system is used to make decisions that harm people, the ethical issue isn't the AI's feelings, but the real suffering it causes to conscious minds. Idealism can guide us in creating technology that respects the primacy of consciousness, ensuring that our innovations enhance, rather than diminish, the experiences of those who truly feel. Idealism also opens up new possibilities for technology that works with consciousness, rather than trying to create it. Imagine devices that help us access the universal mind more directly, tools that enhance meditation, amplify creativity, or even connect us to the experiences of others. Some researchers are already exploring brain-computer interfaces that can alter our states of consciousness, like neurofeedback devices that help you enter a meditative state by monitoring brain waves. Idealism suggests that these technologies aren't just changing your brain, they're helping you tune into the universal consciousness, accessing deeper layers of the mind that connects us all. This vision of technology aligns with idealism's core insight. Consciousness is fundamental, and our tools should work in harmony with it, not against it. Original scenario: a conscious interface. Let's imagine a future where idealism shapes technology in a profound way. A speculative scenario I've created called a conscious interface. Picture the year 2075, a world where science has embraced the idealist view that consciousness is fundamental. You're in a sleek, minimalist room, the walls glowing with soft light, a faint hum of energy in the air. On a table before you is a device called the Mind Link, a small, crystalline sphere that pulses with a gentle blue glow. It's a brain-computer interface, but not like the ones we have today. The Mind Link doesn't just connect to your brain, it connects to the universal consciousness, the cosmic mind that idealism says underlies all reality. Scientists have developed this technology by studying quantum effects and altered states, learning to amplify the brain's natural ability to access the deeper layers of consciousness. You place the Mind Link on your forehead, feeling a cool tingle as it syncs with your neural patterns. You close your eyes, and suddenly, you're no longer in the room, you're in a vast, shimmering space, a mental landscape that feels both infinite and intimate. Colors swirl around you, not attached to objects but existing as pure sensations: emerald greens, sapphire blues, golden yellows, blending and shifting like a living aurora. You hear sounds, To a harmonic hum, a chorus of voices that feel like they're coming from everywhere and nowhere, a melody that resonates with your own thoughts. You realize you're not alone. You sense other minds, their presence like warm lights in the distance, each one a wave on the ocean of universal consciousness. With a thought, you reach out to one of these minds, and instantly, you're sharing their experience. You feel what they feel, a surge of joy as they watch their child take their first steps, the warmth of the sun on their skin, the scent of grass in the air. It's not a simulation, it's a direct connection, a merging of consciousness made possible by the mind link's ability to tune into the universal mind. You share your own experience in return, the excitement of this moment, the wonder of this technology, and you feel their response, a ripple of curiosity and awe that mingles with your own. You communicate not with words, but with shared sensations, a language of emotion and thought that transcends the physical.